We've looked at ways of calculating values from our sets of data to help us compare them to other sets of data and to help us know a little bit more about them. What we're going to look at now is a method that enables us to display the data in a diagram that gives us a lot of information all in one place. It's called a stem and leaf diagram. A stem and leaf diagram is just a way of representing the data. It enables you to show all of the data that you have and makes it a little bit easier to interpret. And they're usually used when there's large amounts of numbers to analyse. It just makes things simpler to write down on a piece of paper and look at. So scores of sports teams, temperatures, rainfall over a period of time, test scores, as we've already looked at, are all examples of when stem and leaf plots could be used. Let's have a look at an example and show you how we build them. So this particular stem and leaf diagram is going to show the number of people attending a load of different doctor surgeries on one particular day. So let's have a look at this and see if we can work out how this is built up. So this part of the diagram is called the stem, and in this particular example the 2, the 3 and the 4 and the 5 are meaning 20, 30, 40 or 50. So that's the first part of the number we're looking at. So the 2 is 20 something, the 3 is 30 something and so on. That's called the stem. Then we have the line that separates the stem from the leaves. And hanging off we have individual leaves. So the 6 there means that we have a number 26 in the set of data. Then the 7 means we have a number 27. And if you go down to look at the 30s and 40s and 50s, we've got 31, 32, 32, 33, 34, 37, and then we've got 40, 42, 42, 42, 43 and so on. So this nicely tells us how many of each number are in which of those number ranges. In this case we've chosen to use tens as our stem, but if we had lots of numbers in the hundreds range we could choose hundreds as our stem and so on. So organising the data in this way helps us to see the spread of the individual items of data, and we can see very clearly, for example, here we have more items of data in the 40s than we do in any other set of tens. As I'm sure you realise, it's going to be very important that you must always remember to include a key that shows that, for example, the 2 and then the line and then the 3 means 23 people. This makes it easier for people to understand what the data in your stem and leaf diagram actually mean. As we'll see, the stem and leaf diagram can be useful for helping you work out some of the statistics we've already talked about. And as we've said, for getting a general feel of the pattern of data, it's very, very helpful. Let's have a look at how it might help us calculate things. So here we go, there's our stem and leaf diagram again. So the mode, very easy to see the mode here, isn't it? We can see that there are 3 lots of 42 very, very quickly, because in essence this data is now organised into order. So the mode of 42 was very quick to see. The median is also easy to find. The median, because there are 20 data points here, the median is the average of the 10th and the 11th data points. So if we look there, count along all of our data points, we can see that the median is the average of 42 and 42, which is simply done as 42. The mean, unfortunately, you're going to have to go and calculate in the usual way, so adding up all of the values, and that is always going to be by far the simplest and quickest way to do that. So you end up with 40.5 or 41 to the nearest person. And obviously you can very quickly work out what the range is, because you've got the highest number and the lowest number there. Subtract one from the other, and in this case you get the answer of 30. So the stem and leaf diagram is a really simple and straightforward way of organising data so that it gives you a very good visual representation of that distribution. If you look at this, it's almost like a bar chart formed for you, and it also gives you a quick way of working out the mode and the median, and also finding the range. The mean, I'm afraid, is always going to be a bit of a slog.